Welcome back to the math sessions that we're spending together. What I want to do today is I'd like to start looking at equations. Okay, it's a big section of the work. As you know, the old jokes about let x find itself, etc., etc. Essentially, we're going to be looking at how to solve different kinds of equations. Now, if you remember back, there were some very straightforward, very easy ones. But just to recap the rules, what did we do? If we said we had, for example, 2x minus 10 equal to 3x plus 5, okay? Then basically what we had is we had over here, what was the rule? The rule was x's to this side here and variable constants to that side, okay? So we move the x to the left-hand side and everything, the right-hand side has got all the numbers, right? How do we do that? We do the exact opposite, don't we? If we've got a plus, we subtract. If we've got a minus, we add. If we've got a multiply, we divide. If we've got a divide, we multiply, okay? Let's just quickly recap one or two. What am I going to do here? I'm going to say that is 2x minus 3x equal to 5 plus 10, right? 2x minus 3x is minus 1x is equal to 15. I don't want minus x. We want plus x. So what do? We say, right, therefore multiply through by minus 1. Therefore, x is going to be equal to minus 15. All right? Let's have a look at a one involving a fraction, for example. Let's say we had 3x over 4 equal to a half x, I don't know, plus 3 minus 6, let's say. All right? Now, let's see what happens here. This is a half x, right? We have to bring the half x to that side and take the 6 to the other side. Okay? So let's have a look. 3x over 4 minus a half x equals 3 plus 6. All right? Yeah, I'm aware you could probably do that in one step in your head. 3/4, what do we do here? Let's just go through the process, because when we've got x's at the bottom and brackets, we're going to go through the same process. What do? We find the lowest common denominator, which is 4. We draw a line. All right? 4 divides into 4 once, so we bring down the top. It's 3x times 1. 4 divides into there, leaving us with 1. Minus 1 times minus 1 is the numerator here, right? Let's just ring it so that you can see. It's minus 1. I bring it down to there, just like I brought the 3x down to there, right? What do I do now? I say 2 goes into 4 twice, like so, is equal to 9, right? Now, we've now got 3x minus 1 over 4. Now what have I got? Let's just put this down. 3x minus minus 2 over 4 is equal to 9. What do I do next? It's just simple. We want to get rid of that 4 at the bottom. All right? So if we've got the 4 at the bottom, I must do the opposite. What is the opposite to divide by 4 is times by 4 over 1, right? To get rid of that, which then leaves us with 3x minus 2 equal to 4 times 9, okay, 36. Then I must add 2, 3x equals 38, x is equal to 38 over 3. Okay, so essentially what we've done there is we've gone through a process of taking the x's to the left-hand side, the constants to the right, and we just perform the opposite operations. If it's divide, we multiply. If it's multiply, we divide. So what we want to do is we want to get rid of essentially all the fractions, okay? Because nobody likes working with fractions, so we try and get rid of them, all right? So let's just have a look. Just before we move on, what if they said to us, and check? What does it mean? Essentially what it means is check your answer, right? Now you know in any equation you've got the left-hand side and the right-hand side, right? You have solved for x to make sure that it's equal. Whatever that operand is there, we've tried to make sure that it's equal. This, you know, the equals or less than, greater than, we'll get to inequality some other time. But left-hand side equals right-hand side, all right? Now, if we have found an x, what do we do with it? Let's say we got x equal to -3. What you do is you substitute back. So you take -3, put it into the right-hand side and get an answer. And put it into the left-hand side, get an answer. Okay? Look if those answers are equal. If they're equal, then you've got the right answer for x. Okay? Then that they will ask you to do is to check your answers or verify or whatever, which means essentially put it in. Now let's have a look if, for example, all right, let's just take this, 1/2 minus 2/3 plus 1/2 minus 3 1/4. Okay? How do we add all that lot together and subtract them? Well, the first step is, can you see over here, we have to convert those. So we're going to say it's 1/2 minus 2/3 plus 2 times 1 is 2 plus 1, 3/2, minus 12, 13/4. What do we do next? Next we get the lowest common denominator. The lowest common denominator here is 12. So what do? I take 1, I bring it down, I open another bracket. 2 divides into 12, leaving me with 6. Bring down the -2. 3 divides into there, leaving me with 4. Okay? Plus, bring down the 3. 2 goes into there, 6. Minus 13, okay, and 4 goes into there 3 times, all right? So essentially, what we're going to have is we've put it all over 1. We haven't done it as equivalent fractions. You could have, but it does get a little bit messy now that we're starting to use slightly more complicated denominators, okay? Let's have a look. That comes to minus 23/12, which we don't leave it like that. That's minus 1 and 11/12, okay? Now, let's look at some of the ones, the typical kind of things we're going to start seeing now. Let's introduce x into this, okay? Let's start off with x over 4 minus 2x over 3 equal to 2 and 1/6. Okay? Now, all kinds of fractions are in here. What do? First, we have to convert that. Okay? We don't work with them in that form, so we convert it. 6 times 2 is 12. That is 13/6. So I've got x over 4 minus 2x over 3. My next step is to do what? All right. My next step is quite simply going to be, I will be there now. Okay. Let's just put that there. My next step is going to be to see, okay, what's the LCD? The LCD, I've got to look here, here, and there. Right? Because they're all going to be converted. And I draw a long line and I say that is going to be 12. Okay? Not too interested in the moment at the 6. We'll deal with him in a sec. Right, so if I do this, what do I get? Well, I say we bring down the numerator is x. 4 divides into 12 and it goes 3 times. Minus, remember, bring down the numerator. 3 goes into there 4 times. Equal to 13/6. Okay? That leaves me with 3x minus 8x. Okay? All right? 3x minus 8x. Okay? Over 12. Equal to 13/6. Right, now, here comes the part that we've got to, that we're going to enjoy doing. We don't want 12. We don't want a fraction. So what do? We get rid of the fraction. I'll just write it down. We multiply through by the LCD. It's 12. So if I take 12 like that and I multiply oh, hang on, why I have to do what I do to the left side, I must do to the right side. So I have to multiply everything by 12. What happens now? Well, straightforward, right? This 12 cancels with that, which is what we wanted. So we end up with 3x minus 8x is equal to, and that cancels there with a 2, okay, and that I think is going to be 26. Finally, we can now got a normal equation, minus 5x equals to 26. I don't want minus 5, so we do the opposite. It's minus 5 times x. Can you see it there? So I divide it by minus 5 to just leave me with an x. Okay. Which is x is going to be, because minus over a minus is a plus. So x is therefore going to be equal to 26 minus 26 over 5. All right. And you can change that down to a, it's 5 1/5. All right. Okay. So essentially what we've got here is we're building up a method. Okay. Now you're going to see them getting bigger and bigger and bigger and bigger and bigger, and next year they get even bigger, right? The method, the process, the recipe is the same. Okay, nothing's essentially going to change. When we start, we're going to start with factorizing, blah de blah de blah, and we're going to solve for x. All right. Now, what happens if we've got an x in the bottom? All right. Okay, let's have a look over here. 3 over 2 minus 4 over 7x. Equal to 2 over 2x. You say, oh, hang on. What now? Well, first of all, this x here is on the wrong side, isn't it? We don't want it sitting on that side. We actually want the numbers on that side. So let's rearrange. We've got minus 4 over 7x minus 2 over 2x equal to minus 3 over 2. Okay? That's straightforward, isn't it? Now, what can I do? I now want to subtract these terms, all right? Well, first of all, I can say, just a second, hold on. This doesn't really, I don't want to work with minus signs. So let us multiply everything through by minus 1, shall we? So if I multiply by minus 1, this is going to change to 4 over 7x plus 2 over 2x and 3 over 2. Right. Now, what are we going to do with this lot? Well, we've got to say to ourselves, how do I find the LCD here? This is what you do. Okay. Remember, first of all, draw a line, and that's 3 over 2. You could have left the 3 over 2 on that side, by the way. It makes no difference. Okay, let's have a look here. Remember, 7x is actually 7 like that, hey? It's 7 times x, 2 times x, all right? So at the bottom, you take the first one. You take this one and bring it down there. That is your first term, right? Then we go to the next one and say, there's a 2. Do I have a 2? No. Do I have an x? Yes. So I don't use that x, right? We're going to go through this a few times as we do the others, but bring down the very first denominator, then go to the next one and say, right, what do I already have? I've got a 7. I don't have a 2, so I must use a 2. I've already got an x, so I'm going to use an x, okay? And then I say, right, that is then going to be 14x at the bottom, all right? Isn't it? But let's just leave it as 7x times 2. Right, now we say, bring down the numerator, 4 in a bracket, times 7x, 7x2. What do I do with these two here? Okay. What I do there is I do the following. I actually divide the 7x into there. Can you see the 7 cancels with the 7, the x with the x, leaving us with a 2. Plus 2 times, look at this, 2 cancels there, x cancels there, leaving me with a 7. So we end up with 8 plus 14 over 14x is equal to 3 over 2. Okay? Right, now, my question is this, all right? What do I do next? Well, basically, what have we got here? Okay? we've got a situation where we've got the x at the bottom. So let's just carry on. 8 plus 4 is going to be what? Well, it's 8 plus 4 is 1822, equal to 3 over 2. Okay, now here comes the point where we say, well, just hold on. I don't want that 14x there. Remember, if we'd have had 14x over 22, you would have multiplied by 22 over 14, correct? Because that would have cancelled. Let's just look at it. That would have cancelled with that and that with that and left us with x. Well, in this case, you do exactly the same. Right? You multiply through, and I say, actually, do it. 14x times, like so. Okay? Do it. Don't just say, oh, I know I'm doing it, then do it. Put it down, because we're going to have quite a few terms coming on the top here, right? And it's going to get more technical, more complicated, not technical. Technical, it's the same. That means it cancels. Look here, the 2 cancels with this, that, and leaves 7. Question, could I have cancelled this 14 and that 14? No, because there's a plus sign in between. Okay? Please don't fall for that one. That leaves us with 22 is equal to 21x. Therefore, 22 over 21 is equal to x. Right? So, straightforward and easy at this stage, right? All we're doing is we're following the set of rules that we followed throughout, okay? Let's have a look and say, right, okay, let's retake this one, all right? And we say our thing was 3 over 2, whoops, 3 over 2 minus 4 over 7x equal to 2 over 2x, all right? What is the LCD? The LCD is 14x, right? Now, let us say that we then say, okay, multiply through by the LCD, all right? So, well, let's do that. Okay. We've got 3 over 2 minus 4 over 7x, okay, 7x equal to 2 over 2x. Now, what am I doing? I'm multiplying through, but I must multiply each term by 14x. Okay? Now, we can cross cancel here. This is 2 leaving me with 7x. This is 7x leaving me with 2. 2x into there leaves us with 7. So we're going to end up with 21x minus 8 equal to 14. Therefore, 21x is equal to 22. I just took the 8 over. Therefore, x is equal to 22 over 21. Okay? That way is a bit quicker. Why? When can we use this? Well, we use this when we've only got a single term at the bottom. You're going to see one now that looks similar, but is a vastly different approach to it. Let us say we have a situation. Okay. Okay. Let's say we've got one of these. 1 over x minus 1 equals to 3 over x. Minus 2 over x plus 2. Now, before we go any further with this, what we've got to look at is we say, but just a second, let's just look at something that's very, very critical. I'm going to change this to red. X in the denominator. Very important. Why? Well, what if x, when we solve the equation, okay, what if we get an answer x equals 0? All right? We solve the equation, we do everything correct, and all our arithmetic's right, and our processes, our recipes correct, but we get an answer of x equal to 0. Have a look here. At the top, we have got 3 over x, which means if x was 0, it's 3 over 0. And we cannot do. Which means that we've now come into a situation where we've got x's in the denominator, but there are going to be values of x that are not allowed. For example, what if we got x equal to 1 as an answer? Look at the top, 1 over x minus 1, which means 1 over 1 minus 1, which is 1 over 0. Once again, we can't do it, all right? That means that when we get to a point, and we're going to come to that point in a sec, we then turn around and we say, right, we introduce the concept of restrictions. Restrictions, right? Okay, restrictions in essence is what is x not allowed to be. Okay, in other words, what can't x be? Okay, so how do we do it? We look at the denominator and find values of x where it will cause a 0. So we look at the stuff in the denominator and we find the values of x that will cause a 0. Right? Okay, let's just take the one that we've got here, okay, and let's just go through it as an explanation. Right? Let's take 1 over x minus 1. 1 over x minus 1 is equal to 2 over x minus 2 over x plus 2. Now, first rule is I've got to get everything to the other side. Why? Because I've got my x's, all right? Now, in these, it's better to get everything equal to 0, okay? When we've got this kind of complicated arrangement, we make everything equal to 0, and then we say this plus 2 over x plus 2. Can you see that's come across and we've made a 2? This one comes across and becomes a minus, all right? You take the whole term across because it's a fraction. It's 2 over x. Now, that equals 0. Next, I look for my LCD. Draw a long line. Okay, equals 0. Then what do? First of all, remember, we take the bottom term and we put it in. X minus 1. Okay, that's step 1. Then I say, right, now I go to the next. I say, there's an x. Do I have an x? No, I've got x minus 1. So I must have an x in there. Okay, what is the next term? The next is x plus 2. I haven't got that either. Okay, so in other words, I've brought all of my denominators down, but I haven't repeated any of them. Okay, they're all basically unique in their own terms, right? The next step is to say, right, bring down your numerator from the first one with the sign. So that's a 1 and it's a plus, right? That's a plus. Then what do? We say x minus 1 goes into here. In other words, the x minus 1 cancels out that one, doesn't it? Leaving us with x times x plus 2. Right? We bring down the next one, the numerator with the sign, minus 2. X divides in here, cancelling out x, leaving us with x minus 1, x plus 2. Next, we bring down the plus 2. You can see why I say draw a long line. X plus 2 cancels that out, leaving us with x minus 1 times x. All right? Now, at this point, when you have done that process, right, what you do is this. You go down and a few lines down on the right-hand side, you load in restrictions and a little box. Why I say go a few lines down on the right is we're going to work an answer out here and then we're going to check it. Okay, so what can x not be? Can x be 1? No. X cannot be 1 because if I put a 1 there, I end up with 0. Can't have that. X cannot be 0 because it makes that a 0. X can also not be minus 2 because if I get a minus 2, that makes that term a 0, which I can't have. All right? Now, at this point, the step that we're going to do is this. Multiply through by the denominator. Multiply through by the denominator at this point. The denominator is x minus 1 times x plus 2. You don't multiply it out. In these, you never multiply those out. What happens now? Well, if I multiply through by that number, it disappears because it's going to cancel out over there, correct? And if I multiply it by 0, it's gone. Multiply through by the denominator and it has gone. It's disappeared. So that leaves us at the end of the day with just the numerator. 1 times x plus 2 minus 2 x minus 1 x plus 2 plus 2 times x minus 1 times x equals 0. Right? The denominator disappears. Okay? Then what happens? Well, basically you simplify the numerator. Okay? At this stage, basically I call this drop the denominator. Okay? Drop the denominator at that point. So if I multiply this out, and it's a long process, okay, I end up with this. I end up with 2x minus 3x plus 2x plus 6 equals 0. And we simplify further. We end up with x plus 6 equals 0, x equals minus 6. Then we test. Can x be minus 6? Yes, it can. Therefore, that's fine. I, in fact, can go ahead and say my answer then is going to be minus 6 because it doesn't defy any of the restrictions. What if, for example, we got an answer of x equals minus 2 as well? Let's say we got x equals minus 2 and x equals minus 6. This one is not a solution. Okay? It's not a solution. It's not a valid solution. We can't have it. Okay? Right? That is that. The next one is quite a long chap. Okay? What I'm going to do is I'm going to go on. The next one's got a long denominator in a calc. We're going to go through that as well. All right? And reinforce the steps as we go through. Okay? That'll be in the next session. And I'll see you in that one. Have fun with these. They are messy, okay? And here is where actually you've got to stay very, very focused on a continuous basis. Unfortunately, you've got to just plod through these piece by piece by piece. Okay, I'll be back to go through a few more examples with you shortly.